I'm Anil Kumar. Welcome to my series on Pythagorean Theorem. In this particular video, we'll discuss about Pythagorean Theorem as applicable for grade 9 students. You have been learning Pythagorean Theorem from middle school and you will continue to learn it even by the end of high school. Let's see what really it is. So whenever we're talking about Pythagorean Theorem, we always take a triangle and that triangle should be right angle triangle. So to begin with, I have a right angle triangle here with 90 degrees in one corner. Let me name this triangle as A, B and C. So in the right angle triangle, we'll have these two sides which form the perpendicular. They are called the legs of the triangle, right? So these are the legs or the shorter side, and that is the hypotenuse. Correct? Hypotenuse is the longest side of a right triangle. Now what we find is that these sides are related, and the relation is that sum of squares of the smaller sides is equal to the square of the longer side, right? So if I name the sides as small a for the side opposite to capital A vertex, small b for the side opposite capital B, and small c, this is the standard way of writing the name of the sides. You could also write AB, AC, BC, but that's also correct. Okay, so the relation here is that a square plus b square is equals to c square. Remember, whenever you write this equation, c is the longest side, the hypotenuse. Correct? So that is the Pythagorean theorem. It is very helpful, and we have seen hundreds of examples being solved using this particular equation. So it is basically sum of squares of the legs is equals to sum of square of the hypotenuse. Right? At times you may have to rearrange it. Sometimes if you want what a is, you could write this as a square equals to c square minus b square. You could write b square equals to c square minus a square. So these are the different ways you can write the same equation. But in case you want to know what c is given a and b, how will you do it? Well, let's sketch another triangle and then figure it out. Okay. So what we will do here is we will take two sides as, let us say, 3 and 4. 3 and 4 is a very common number to be taken for a right triangle. You know why, right? This number is very special. Let's find the opposite side. So here, let me call this side as C for the time being. How do you find the length of hypotenuse? That is the question, correct? So we know C square is equals to 3 square plus 4 square. Now 3 square is 9, 4 square is 16. When we add, we get 25. So we get C square is 25. So what is C equals to? To find C, we have to square root 25 and use our calculator. If you use calculator, in this case it is simple. 5 square is 25, so I know square root of 25 is 5. That is how we could find the length of the third side, correct? So this is a way to do it. Now let's take up an example where we really know the hypotenuse. But in that case, how do we find the other two sides? Okay, this time let me take an application question. We'll take a square this time, and let us say that this is a square garden, and in this garden we know if we go diagonally across, then how much we are going to travel. And let us say this path is let us say 10 meters, right? So I'm taking a value in which calculator will be required. Okay, so it is a square garden. It means what? It really means that all sides are equal. So this side is equal to the other side, and we know hypotenuse is 10 meters. Since these sides are equal, I can name them by the same letter, A and A. Now I know 10 square is equals to A square plus A square. So I can write here as A square plus A square equals to 10 square. A square plus A square is 2A square, right? And 10 square is 100. So what is A? Well, let's go one more step. A square will be 100 divided by 2, and that is 50, and A is equals to square root of 50. Now we can use the calculator to find this value. Sometimes we have to write exact values. sometimes round to one decimal place. If we have to write exact value, we will get the value as 50 is 2 times 25, 2 times 25, 25 square root is 5. So we get 5 square root 2, right? So let me show you with my calculator. It's a very good calculator. It really gives you answer in both. So we have 50 here within the square root, and it is equals to 5 square root 2. If I have to convert to decimals, what value do I get? I get 7.071. Now it really depends on the question. If you want to round this answer to one decimal place, in that case you get 7.1 as your answer. Since the units are in meters, don't forget to write the units, right? So both ways, write units. So that is how sometimes you do application questions. Now one of the related question could be that this is the garden in which if you go right diagonally, it will take 10 meters. How much distance, extra distance will you travel if you go along the boundary? So that could be an application question for you. Now here is another application question where we are going to use the Pythagorean theorem. Now the question here is, I have given you the area of the rectangle. So area of the rectangle, let us say, is 20. And I'm saying the area of the rectangle is 20 and the sides are, I'll not complicate it, I'll just give you the side lengths. 20 is 4 times 5, for example. It could be 10 times 2. But let us take for this example 5 meters and 2 meters. Area becomes 20 meters square in that case. Now the question here is, if the area of the rectangle is 20 and I don't give you both the sides, I just give you one of the sides, right? So I say, well, my side here is 6 meters. Okay, now it becomes really difficult. So it says, well, I have a rectangular garden, area is 20 meters square. One of the sides length along the wall is 6 meters. Now find the length of the diagonal. Find the length of the diagonal, right? So if I have to find the length of the diagonal, what is that going to be? Now that is your challenge question. How are you going to do this particular question? Well, the idea is we don't know what this side is. You say let this side be A, but we know area is 20. Since area equals to length times width and area is 20, so 20 is 6 times A is my width, right? So A will be equals to 20 divided by 6 is equals to A, right? So we know what A is, 20 divided by 6. Since we have to use calculator, I will just keep it in fractions. How does it matter? Now once we know what A is, or let us use calculator, okay, so we have 20 divided by 6 equals to 10 over 3 decimals. So it is equals to 3.333, let's say 3 decimal places, since squaring causes a lot of error. Now we need to find diagonal length. Let's name it. Hello. Good morning. बना 2 मिनट में फोन करता हूँ जल्दी. 1 मिनट. So let me name this as A, B and C. So what is AC, the diagonal? So we say AC square is equal to 6 square plus A square. A square is 3.33 whatever square, right? And then we can find what AC is as square root of all this. Is that okay? So that is how we can find the length of the diagonal. So let us use calculator once again. Purposely I have kept this 3.33. Do you see that? Now I will square this square. So that is answer square plus 6 square, 36, okay, equal to. So we calculate this value. Again I am keeping it in fractions. And then I get what? I get 424 over 9 as my fraction. And then we will do square root of this answer, right? So we do square root of the answer and then see what is this equal to. Now this time let's convert to decimals. So we get 6.86. So it is definitely more than the length. It has to be. Hypotenuse is always the longest side. 6.86, which I can approximate to 6.9, and the units are meters. Do you get the idea? So that is how we can apply Pythagorean theorem and do so many examples. Let me give you some practice questions for you now. So first of the question for me is that let us say there is a wall, right? So this is the wall, and I want to put a ladder here. And the idea is to reach this spot. The idea is to reach this spot, which is, let us say, 20 meters above the ground. So this is 20 meters above the ground. And we want to know the length of the ladder. We really want to know the length of the ladder, which should be used, knowing that we could come, closest we could come is about 2 meters in this case. So if I know that you can keep it only 2 meters away, then what is the length of the ladder which could help us? If I have more distance, I need longer ladder. Do you see that? So the question is, find shortest length of ladder, right? In this case, diagram is given to you, right? That could be one question for you, and imagine this is right angles for us. And here is a challenge question. So we have a pipe here, we could say a circular pipe, and we want to fit in something square inside. Exactly, fitting, right? So I want to fit in something square inside. What I know is the radius of the pipe, right? So what I know is radius of the pipe. So I know this length is, let us say, 5 meters, okay. 5 meters is a big thing, and we want to make a square inside. That means all sides equal. So what is the maximum dimensions of the square? So the question for you is, find maximum dimensions of the square that just fits into it, right? That is your question, right? So these are pretty good questions to start with, and I'll provide you with some links, and I hope all this helps you to graduate and learn more and be open for learning in coming grades. I hope that helps. Subscribe to my videos and learn a lot. Thank you and all the best.